Welcome, this is Terry Soul, and in this video we're going to create an agent that learns how to steer all by itself, so an AI agent in Scratch. In a previous video I created an agent that could steer on its own. It didn't learn how to steer, we programmed how it steered, and this is it here. You can see it has two sensors that it uses to sense the left and right sides of the track and drive around. In this video, we're going to add to that so that it can learn on its own how to drive, using a very simple but standard form of AI. So let's take a look at this code. This is a little bit different. If you've watched the previous video, I've expanded the code a bit just to save some time. So first of all, I have 4 sprites here. The first one is my car sprite, made it look a little bit more like a car. And then it has 2 sensors out in front, and those are the ones that touch basically the side of the road and let it know when it needs to steer, when the sprite needs to steer. And then we have 2 separate costumes. One is just the right sensor. And so what it actually does is it switches to this costume and then sees if it's touching the road sprite. And if it is, it knows it needs to turn to the left. Then it switches to this costume, which is the left sensor, and if that sensor is touching, then it knows it needs to turn the other way. And so by switching between the costumes and then checking for the touch, that's sort of the trick to making sure that it knows which sensor is touching. If we just used costume 1 and it checked for touching the road sprite, sprite 2, it wouldn't know which of the 2 sensors was doing the touching, and so it wouldn't know which way to steer. Sort of a clever and useful trick. So sprite 2 is just the road, and that's what our checks are against, is are we touching this road sprite? Sprite 3 is new. It's basically the background, and we're going to use this during the learning process so that the sprite knows, or the agent, if you want to think of it as a learning agent, knows whether or not it's run off the road. If it touches the green, then it knows that it's gone off the road, and that's a failure condition that the learning algorithm will take into account. And then the 4th sprite is just the rectangle up here. That's basically the finish line. So if the sprite, the learning agent, gets to the finish line, then it knows it's been successful. And we'll also use a timer to see how long it takes, so that not only will it learn to drive, it will learn to drive faster and faster. And each of these sprites has a little bit of code, but just enough to put them in the right location. So you'll notice that it's all, when the green flag is clicked, go to their starting location. Our main sprite already has the steering code, a variation from the last video, so you can see it steering here. And the way that it works is when the green flag is clicked, it goes to the starting location and pointing to the left. It shrinks itself a little bit so it'll fit, switches to that first costume, and then we set a variable running to 1, and we're going to use this variable to know whether the car should be running, should be moving around the track, or whether it stopped for some reason, like it's gone off the side and touching the green. And then once we set running to 1, we broadcast start, and we can wait or not wait, it doesn't really matter in this case. And then this block, when it receives start, as long as running is not equal to 1, so we repeat until running sets to 0, which it never does currently, it moves ahead a bit and then checks for touching on the left or on the right, so that's the check left or right. And what those checks do is they switch to the appropriate costume, and if they're touching sprite 2, which is the road, then we know to turn. So switch to costume 2, which is just 1 sensor, and if that's touching, turn away from the road. And then check right, switch to the other costume. If that's touching, turn to get back centered. So this is our basic steering sprite. So we want to think about how to turn this into an agent that can learn for itself. And there's 2 things that it needs to learn. It needs to learn to move ahead. So here I have it moving 3 steps at a time, so it goes around kind of quickly. I'm going to say that's part of what it needs to learn. And then it also has to turn. So it has to know turn left and turn right when those sensors are touching. If it didn't know anything, it wouldn't know to move, it wouldn't know to turn, and that's sort of how we're going to start this program. Additionally, these numbers are very arbitrary. Maybe it could move faster, so maybe it could move 5 steps or 8 steps or 10 steps. It will be able to learn, once we have the algorithm running, to go faster and faster up to some limit. If it goes too fast, it's going to jump right off the track. And so I can't just put in an arbitrarily large number here, or it will go off the track. And honestly, I don't know what the right number is. That's why I have a learning algorithm. And similarly, it has to turn, maybe turning 15 degrees. That is enough to keep it on the track, but only when it's going this fast. If it's going faster, maybe it has to turn harder in order to stay on the track. I don't know that either. And so that's why I'm going to set up a learning algorithm in order to learn those things for me. And so the two things that it needs to learn are how fast to move and how much to turn. And over time, hopefully we'll learn those better and better so it can go around the track faster and faster. And so what I need is to store those. So I'm going to need to store the speed and the turning. And so I'm going to create a list. And I'm actually going to create two lists. So the first one I'm going to call best. And that is going to represent the best numbers that I found so far. And I am going to hide running for now, so I have a little more room to squeeze that up. Best is going to be the best numbers we found so far, the best speed and the best turning. And then I need another list, which I will call test. Those are the numbers that I'm currently testing. So the way that this learning algorithm works, and it's very simple, is we have the best numbers we found so far, and then we make a slight variation of them, test that variation. If that variation is better, it becomes the best one, and then we make another variation. And if it's worse, we throw it away and go back to our best so far and make a variation. So we're continually testing variations of the best so far to see if we can find a better best. It's a very simple AI algorithm, but it is a standard one. It actually has a name. It's called hill climbing because you can sort of think of here's our best, and then we're looking for one that's better. And if we find a better one, we keep it, and then we look for another better one. And so we're sort of climbing a hill of better and better performance. So those are our best values that we found for driving so far, and these are the ones that we're going to want to test. So the first thing I need to do is set up those values, and that can be part of when the green flag is clicked. So I'm going to add, before I start running anything, to my test. I'm going to use the first number is going to be how fast I go. And I know it's foolish, but I'm going to start by going with a speed of 0 because I'm pretending, at least for now, I know nothing, so it can learn as much as possible. And then the second number that I'm going to put in is also 0 to test. And that's going to be how much it turns. And so initially, it'll just sort of sit there and do nothing, which is okay. And then it'll learn from that. And the third thing that I need to add to test kind of doesn't matter, but it is the score. And so we're going to take that score and replace it with whatever score it actually earns by going around the track. Okay, so there, I guess really, maybe I'll start with moving 1 and turning 0 just so we can see something happen. And then let me do the same thing, but these are going to be for best. So I'm going to start with some values for best. And again, it's going to be 1,000, which is a very large and therefore very poor score. I want to minimize that score. A lower score means that my agent has learned to do better. And we also need, before we do anything else, we should always delete all of the old values. Every time we run this, it's going to add more values unless we delete all the old ones. So now, I don't need to run it, but you can see it sets the best and the test scores. And then the other key is, so now when I go to move, I'm not going to move 3 steps anymore. I'm going to move based on the test value. So I'm going to take this first test value, and that's how much I want to move. And similarly, when I turn, I'm not going to turn by 15, I'm going to turn by 2 of my test. And by 2 of test, I mean I'm going to use the second value. And so if we run this now, what you'll see is it goes very slowly in a straight line right off the road. And the reason that it goes in a straight line is because when it's touching the sprite, it turns based on item 2, and item 2 is 0. So it doesn't turn at all, and it goes right off the road. Of course, just running off the road is not what we want. We need to check that it is touching sprite 3 to know that it went off the road. So now I need another block to keep checking if it has gone off the trail. Let us put that together, and then it'll start to make sense. So similarly, when I receive start, I want to use this same repeat loop. So I'm going to duplicate it, but I don't want this for the inside anymore. This is going to be checking if I've run into sprite 3, or for that matter, sprite 4 eventually. But for now, we'll do sprite 3. So I have an if touching sprite 3. And so if I touch sprite 3, which is to say I go off the road, we want to do two things. We want to stop running. So I'll change the value of running to 0, which will stop all these loops. And then I also want to update the score over here for test based on having gone off the road. So let's do both of those things. Oops, variables. I'll set running to 0. I'll replace the third item of test with a score, and I'm going to say if we run off the road, that's a 999. So it's a little bit better than the starting value, just so that we can see a value get swapped over. But basically, that's still a terrible value. And then the last thing I want to do is broadcast a finished. And the finished will say, I'm finished with this test run, reset the values and try again. So I need to broadcast a new message, finish. And so if we run this, we should be able to see a little bit of that work. So everything stopped, and the score for test got updated to 99, and everything stopped because running was set to 0, and finish doesn't do anything yet. So now we can put in the when I receive finished and start working on that code. So a couple of things need to happen. When it's finished, we do need to reset the sprite back to the starting location. So I'm going to grab some of this code. I don't need to reset the size, and I don't need to add any of those other things, so I'm going to toss that part, but I do want it to restart at the right location. And then what I have to do is compare these two values, so the best score that I've seen and the new score that test just generated, and see which one is smaller. So I'm going to do an if comparing those two scores. And I'm looking at the third item of best and the third item of test and comparing them. So if item 3 of test is less than item 3 of best, that means that this new test score is better, lower is better in this case, and I need to copy all of those values over. So gets a little complicated, but replace item 1 of best with item 1 of test. And then I'll duplicate that and duplicate it again. And this will be item 2 and item 3 and item 2 and item 3. And so now this will copy those values over to here, and if we run it, you can see that they got copied over. So that's good. And now I want to do another trial, and so for next trial, I want to change the test values and have them be variations of the best value. So I'm now going to do something kind of similar to this, so I'm going to duplicate it, except here I'm replacing test. But I don't just want to replace them with the values of best. I'm going to do that to begin with. And actually, item 3 I don't need at all, because I don't need to copy the score back over. I just need how fast should I go and how far should I turn, and put those values into test to try them out. But I don't want the exact same values, because if I use the same values, it's going to drive exactly the same. I said I want a little variation of them. And so for variation, I'm just going to use random. So I'll pick a random number, say minus 2.0 to 2.0. And I will add that to item 1 of best. And then for the velocity, because I always want to be going forward, I'm going to grab the absolute value and stick that in. And you might think about what would happen if I didn't use the absolute value. We can run that as a test later, but consider what will happen if we don't use it. And then I can actually just duplicate this. Except in this case, I want it to be item 2. So I'm going to take the best speed, add a random value to it, and put it over in test to try it out. And if we run this, you can actually see what happens, right? We start, they're both 1,000. We get here, test was a little better because it was 999. So we copied it over into the best, and then we took the best values and copied them back into test, but with a little bit of randomness. And so this time we're going to test these values to see if they've made things better. Okay? And now that that's set up, we can just run things again. So I will broadcast start, but before I broadcast start, I need to set run back to 1, because that's what makes everything work. Right, so now it will keep trying those new values over and over again. There we go. Oh, and there it steered a little bit negative, and it's moving a little slow. You can see this time it's steering a little bit positive, so it's kind of staying on the track. But it's not doing a great job of staying on the track. It's going to run off again and stop. But as you can see, it's trying different values. It's trying to learn how to get around the track. It doesn't get any bonus for getting further, unfortunately. So the only thing it can really learn, and it can't even learn that yet, is if it gets all the way around to the starting location. And so that's the next thing we need to put in, is if you get all the way to the start, that should give you a much better score. So in the interest of time, because I'm a little impatient, I'm going to make this random bigger. So it's going to try a bigger range of angles. And then we do need to put something in so that when it gets to the start, it is learned that it gets to the start. And I'm just going to use this block we already have here. So we have if touching sprite 3, I get a terrible fitness because I've gone off the track. We can also put in an if touching sprite 4, then I get a better fitness because I've gotten all the way around to the beginning. Okay? So let's put that in. So I'll set it here, if touching sprite 4, and we want to do sort of the same thing. We want to set running to 0, so we'll stop everything from running. Right, same idea. If we go off the track, we stop running. If we get to the finish line, we also want to stop running so that we can update our values. And we will want to broadcast finished. But here's the tricky part. In between those two, we need to give ourselves a score. So I'm going to put that in, and then I'm going to worry about how in the world we're going to figure out what that is. So we need to set, excuse me, that is the wrong choice because we're looking at a list. I need to replace an item in the list, item 3 of test. So let's take a look at this for just a second. If we're touching sprite 3, we get a terrible value because that means we've gone off the track. If we're touching sprite 4, we should get a better value because it means we've gotten all the way to the beginning. And so I could just put in, some arbitrarily good value like 100. And now, if we run this, we should eventually see it learn to get around. It may take a little while. But here's the problem. If it gets around once, it doesn't matter how long it took to get around. every time it gets around, the score is the same. It's 100, which means it will never get any faster at going around the track. So what I really want to do is put in a timer that measures how long it took to get around the track. And if it gets around the track faster, then that becomes a better score. And so for now, you'll see this actually might succeed. So that was pretty quick with this turning of 3.9, but it's going very slow. I'd like it to be able to learn to go faster and faster. So let me take this when I receive finished, and I'm just going to set it down out of the way so that I can put in a timer loop. And if we watch in a minute, the sprite may come out from behind here. There we go. And then this will be updated to 100, and it should start over using similar values. So there we go. It's 100. Now, at that time, it tried to turn in the wrong direction. This time, it's a stronger turn, but a much slower speed. Another problem without a timer, we're going to wait a really long time for something to happen. So, which is a long way of saying, let's make a new variable, timer, and I'm going to want a new loop here, which is again based on when I receive start. So, when I receive start, I'm going to set my timer to, I don't know, we can set it to say 20 for 20 seconds. And then we're going to use the same sort of repeat until running is 0 loop. In fact, let me just duplicate this. That'll be a little easier. And as I go through, what I'm going to do is subtract from my timer. Notice why we need a timer. This is going to take forever. So I'm going to change my timer. Let's do this by minus 0.1. And then because it is meant to be a timer, I'm also going to wait 0.1 seconds. So this will really be a timer for 20 seconds. Okay? And then we need an if to see if the timer runs out. So we'll go to our variables, grab our timer. If timer is less than 0, we've run out of time and we should stop. And the stop conditions are basically the same sort of thing we've seen over here. So I'm just going to duplicate this little piece and put it in. So I've run out, if I run out of time, I'll set running to 0. I'm going to stop that because I'm impatient. I'm going to replace item 3 with some score. And so what I might do here is say, well, running out of time is a little better than going off the track. So if I go off the track, that's a 999. If I run out of time, that's only a 998. Still bad, but a little better than going off the track. So this allows us to stop sooner and not have to wait forever, which is nice. But it has another really handy feature, which is now if I get to the finish line, I can use that timer as my score. So that is what I'm going to do, and it may take a minute to sort of think about this. So if I get to the finish line, that is to say sprite 4, my score, or the agent score, is how much time is on the timer. Let's think about that a minute. So I think that is not actually what I want. I put it in, but we can think about it because it means that if I go around the track super fast, there's a lot of time left on the timer. So I actually want how much time I haven't used up, if that makes sense. So I'm going to go in here and grab an operator. I'm going to do my minus, and I'm going to do 30 minus the timer. So if it takes me 29 seconds to get around, then the timer will only have 1 second left on it. It takes me 29 seconds to go around. The timer is counted down to only 1 second, and this will be 29. On the other hand, if I zip around in 1 second, the timer will have 29 left, and this will be a 1. So the faster I go around, the more time is left on the timer. Maybe I should have called that an hourglass. The more time is left in the hourglass, and the smaller this number will be. And it turns out that's all we need. So let's go ahead and run this. Again, we're starting with our really poor values and going off the track. We can see here we've got a little bit of turning, so it is turning a bit and the timer is counting down, but I don't think it's going to make it all the way around. So we have to be kind of patient here until the timer counts all the way down, and this score should be 998, so it should copy these over. Staying on the track is a little better, even if you run out of time, than going off the track. And so now it's going to try again, and here it's moving a bit faster, and it's turning a bit more, and maybe, if we're lucky, it'll actually make it around the track. So you can see the timer counting down. Yeah, I don't think that it's going to have quite enough time to get around the track. In fact, we might need to put a little more time on the timer in order for it to ever succeed, but we'll see. There we go. So now it's starting over. Now it's got a negative turn, which means it's going to turn the wrong way. So you can see, oh, it turned the wrong way. There is a setting in Scratch, if you're not familiar with it, under Edit, where you can turn on turbo mode so things go a lot faster. It'd be a good idea here, but I sort of want to see what's going on. So it's nice to be able to watch it. In turbo mode, we couldn't. And of course, it's hidden behind our lists, but it should come out eventually. As you can imagine, what this is really doing, it feels a lot like trial and error, and a lot of machine learning algorithms do have a pretty significant element of trial and error to them. But once it starts to do well, once it gets around that first time, we'll see that it gets faster and faster as it goes. Okay, so once again, we're going to run out of time. So in the interests of speeding up the video, we've got two choices. I could put more time on the timer, which would allow it to actually finish, or because I know that we want to be going pretty fast, I could increase, and this is what I'm going to do down here, the amount of randomness for the speed. So this will allow it to search a little faster. So there we go. Cheating a bit because I already know in advance that I want a pretty big speed there. And so right away we get a speed of 1.8, and it's probably, yep, I went off the road anyway because it wasn't turning enough, but this looks promising. Nope, not quite enough, and this one it's going to turn the wrong direction, but it's doing sort of what we want, trial and error, to see if it can find some values that will work. Let's see, is this going to turn enough? Nope, not quite. So too fast relative to the speed that it was turning at. Here we go. Oh, that's good. So it made it around the corner. Now the question is, do I have enough time left on the timer for it to actually succeed? Maybe. Got a few seconds left, Yep, it looks like it's going to make it. Fantastic. So that becomes the new best with a score, notice, of 26.5, because that's how much time it took. And so now it's going to take this best value, randomly change it for its new test values, and hopefully, because it's working from a better starting point, a better best, it's going to come up with better test scores eventually. I almost want to put in a button, you might do this on your own, a button that I can say, nope, that looks like a failure, try again. Let's see. Nope. So going a little too fast to turn enough. Ooh, this one might succeed. Yes, so notice that the best score has improved because it's going faster but also turning more sharply. And now going faster and turning more sharply, I think it might even succeed again. Yep, now there's only 14 seconds left on the timer. No, excuse me, it only took 14 seconds. So already it's gotten quite a bit better. Well, in fact, when it started, it just went right off the track. This one's going to run out of time. But you can see this is really the basis of almost all machine learning algorithms, oddly enough, is within the code there are some numbers, and we want to find the values of those numbers that makes our agent behave properly. In this case, it's only two numbers, which makes the learning process more straightforward, where in something like a neural network, there might be millions of weights that have to be learned. But the idea, at least for many AI algorithms, is simply how do you learn the numbers that let you behave right? Oh, there, now it's going even a little faster. Of course, it also runs off the road a lot because as it goes faster, it has to turn harder. And that's part of what makes AI tricky, is it's not enough to just say, I need to go faster. If the agent is going faster, it also has to turn harder. And so it has to learn both of those values at once. And you can maybe imagine if we had a more complicated trail or more behaviors, right? You could accelerate, but you could also put on the brakes. Maybe there are more sensors so you can sense further ahead. That leads to more numbers that all have to be learned together, right? It's not enough to just say faster and faster. You also have to appropriately adjust your steering. And there, I think it just got a little bit better and a little bit better. So let me blow this up and we can watch it run around. So right now it's taking 12.3 seconds to get around the track. That one it ran off, and so it got this terrible 999 score. This one, not any better. There it's going a lot faster, but that causes it to crash. So lots of trial and error. This one it's going to get around, but it won't be a higher score. So there we go. We have in Scratch an agent that not only is self-steering, but has taught itself to steer, right? These numbers that it's figured out, if I go this fast and I turn this hard, I can get around the track in 12.1 seconds. It figured out for itself. And notice they're not the numbers that I started with. I started with a much slower speed and a smaller turning. It figured out, it learned. It's an AI. It learned on its own to do better. So there we go. Thank you.